Okay, so we're going to continue with boxes and devices. But before that, we are going to make sure that we're on the same page with some things here. Where is our class portal? Right here. And I'm going to, well, I'll make myself look like a student. So you're going to see what I see. Content, course outline. Go down to the second file. I'm going to zoom in so you can see it. Here is our course plan. And let's take a look what's going on here. It is October 17th today. So October 17th, Monday, which is today, to October 21st, which is Friday, which is on Friday. We are going to have a test distributed this week. The only thing is about this test, it is going to be available this afternoon. And I will send an email to everyone and I'll put in announcements when this test is available because I need to include this lesson today into this test. And you will be able to carry it on until Thursday night, which is Thursday, 11:59 p.m., which is 1 minute before midnight. Please make a note, this is not Friday. This test is available, going to be today late afternoon till Thursday night. The reason for that is that we have something like this here in our calendar. Midterm, I have to submit the midterm marks on Friday. So if I leave the test till Friday, I won't be able to have that. I won't have that test available for the marks. So okay. Just so we know. And the test is just as it was before. As far as the logistics, so you know the way it is going to be conducted, and what else? Yeah, it is going to cover pretty much everything that was on the last quiz, plus the device boxes. And this test will be worth 15% of the whole course. Okay, all right. Let's go to the boxes and devices now. I'm going to just clear my screen. I'm going to clear my board. There we go. So I have it ready for you. And here's the pen. Okay, good. All right. So boxes and devices. Let's continue with this. This is continuing from the last week's class. That's part 2. And as far as the posted lecture notes, both parts 1 and part one that was last week and part 2 that is today, they are included in one PDF file, right, which is already, which is already available for you. Right? All right, so let's take a look at what we have here. Box and devices part 2. Oh, come on. First screen. All right, what do we have here? We have a single gang box, which is pretty much the same size of the utility box that we're playing during our labs, lab number 2. Some of us haven't done that yet. We're going to do it this week. And some of us already have done the lab 2, which involves single gang box. However, we already talked about what single gang is. This is laying sideways, but if it were put the right side up, which is usually what it would be, you would know that this size, this dimension right here is 2 inches, because a single gang box is 2 inches across. And So it's 2 inches across here and 3 inches down. So it's 2 by 3. And if you want to make another, like a double gang box, you would have to add two of them if they were gangable boxes. However, this one here is not gangable box. What is a gangable box? A gangable box is one that you can disassemble in a way that you can join that with another single gang box, which is also gangable and disassemblable, and you can make one out of these two, right? But this is just a box standing on its own. It is not a gangable box. It's a single gang box. I keep saying the word gang or gangable a lot today, so it seems. All right. So what can we tell about this? We can say about this box here. Well, you can tell that it mounts on the side stud on the timber framing, because this will be the mounting bracket. It would just um, well, let's just flip it around here. Can I do that? Rotate, view, rotate, view, clockwise, counterclockwise. All right, so that's what the box looks like. You can have it this way, or you can have it, well, the other way. So the bonding terminal will be on top or on the bottom, doesn't matter. And depending on which side of the timber you are mounting it to, this mounting bracket could be on the left or on the right. Well, basically, yeah. These are those wings here. You would put those against the timber. Why do we put that against the timber? So there's a 1/2 inch here sticking out. What's that? It's to provide for the drywall. So normally on the timber, it would stick out 1/2 inch. But when you put the drywall is going to make it flush with the surface of the box. So that's why we have those wings here. Okay? Now, what can we can see now? This is a plastic box instead of a metal box. We need still we need to have the bonding terminal, but we can't bond the or ground the um, plastic because it's a dielectric, and dielectric is a material that does not conduct electricity unless you put like really a lot of volts through them, and it just basically breaks it down. But for the most part, it's considered a dielectric plastic, right? So it doesn't conduct, so you can't bond it. So in order to have a bonding terminal still, we have here the bonding terminal that extends to one of the screw terminals. Why do we have that? Well, still we have to have the bonding terminal if we are doing a regular installation. So let's, for example, some of the devices such as duplex receptacle, they would have a bonding screw terminal, so that you have to still put it to something. But also some of the devices such as let's say single pole switch, and we'll talk about what that is, just like a light switch. They come in two different versions. Some of them will have the screw terminal for the bonding, but some of them will just not have it. They just have the terminals, the connections, the working connections, if you will. So how is that being? It still has to be bonded. Well, if you put it against the metal box and the box is bonded or grounded, then those two metals are touching and they're being fastened to with a screw. So that means it makes it the whole thing bonded. But if it's a plastic, well, you touch the plastic, there's no conductivity between the plastic and the bonding terminal. So it is basically brought out right to one of the screw terminals. So then the chassis of the switch, and we will look at the pictures a few slides down the road, the chassis of the switch is touching this bonding terminal, which means it is bonded. Or if you have the bonding screw terminal, you can still put that against. So it's either or you can do, as long as it's bonded. And remember what the difference between bonding and grounding is? A grounding is if there was any kind of a terminal or a connection point that runs to the ground or something that's called a true ground. and it's connected with one uninterrupted piece of conductor. That means it's grounded. If that piece of conductor is terminated on some sort of a screw terminal of some sort of a device, and from that also it continues, so it's on the same potential, it's connected, continues to the next box and its grounding terminal, then that next box is also grounded, but it is grounded not with a straight wire that goes, or straight conductor that goes to a true ground. It's grounded through another box first, so we call it bonded, that the second terminal is bonded. It is still grounded, but it's bonded. It's just how we determine the difference, how physically actually this thing is connected, right? So here's the bonding. I'll use those terms exchangeably, grounding or bonding. All right, so that's how that's what we can say about this device box. I'm going to go back to the regular view. So rotate view clockwise again. All right, so let's move to the next slide. Yeah, come on, move to the next slide. Here is a 4-inch by 11/16 square box. Right, what can we say about this one here? Well, it does have a knockout. They have the knockouts, which you can knock out. Basically, you can puncture them with needle nose pliers or slotted screwdriver, and they come out, right? It also has a bonding terminal right here. That's where it is. Okay. And it is 4 inches. Sorry. It has 4 inches here, 4 inches here, 4 inches here, and 4 inches here. But because it is, but because it is 4 inches and because it's a square, then we can just say that we only need to mention one side, and the other dimension is the depth of that. Now let's see here what we have. Phone rings. Somebody pink it up. Here is a footprint. So there will be a device which would be called a receptacle. We have two footprints. Footprint is the way those prongs are arranged. Remember when we were talking about the 15 amps and 20 amps, different footprints? I might ask some of that on the test. 50 amp electric range receptacle. And remember, what is a range? A range is a stove. So electric range is electric stove. The piece of furniture you have in the kitchen and you can cook things on, or in if it's an oven. So the whole thing is called electric range. We need 50 amps for that, and this is the footprint that we need to install on the device box. And this one here is a 30 amp dryer receptacle. It's rated for 30 amps, and you see there's a different footprint. So depending on which device you're installing, you will have to choose the appropriate device box, well, device such as receptacle with the appropriate footprint. Next slide. Octagon box. What do we have here? We have 4 inches by 1.5. Okay. Octagon. Octa stands for 8. Number 8. How is it octagon box or octagonal box? Well, look at this. 1, 2, 3, 4, 5, 6, 7, and 8. Okay, there's a question what a footprint means. A footprint, let's go back to the previous one. A footprint is it's the way the prongs are arranged. So if this has a certain footprint, the plug that goes in it has to match the same footprint. So the footprint is the arrangement of the prongs. So see, this is a little, these prongs are arranged this way, and these prongs, they're arranged a little bit different, and they have different shapes. So um, so we only can match the appropriate plug with the appropriate receptacle. All right, so we have 1, 2, 3, 4, 5, 6, 7, 8 corners. Why is it called 4 inches? 4 by 1.5 inch. Well, it's an octagonal box or octagonal box. From here to here, from side to side, is 4 inches because that's what it's specified here. And the last dimension is the depth of the box. Is it a gangable box? No, it's not a gangable box because you can't gang it, which means you can't take it apart and make it more. It would be silly to make to extend these sideways. You can extend them forward because you can buy the box extenders and you can make it deeper, but you cannot extend this particular one sideways. And this one here can hold, let's say if you had 14 gauge conductors, see the AWG, I read it as gauge. So it's American wiring gauge, or you can say 14 AWG, but it's quicker to say 14 gauge. And that can fit 10 of those, and you can fit 10 of those and be legal. And remember what the last lesson that we had, we also learned what we consider as a conductor and what we consider not as a conductor. Like, for example, if there's a piece of conductor that is not leaving the box in any kind of way, so maybe it's connecting one pigtail to another pigtail, that piece of wire is not counted as a conductor. It's just the way it is settled, right? And then all the other ones, just go and look at the the previous lecture. Now, if it's a deeper box, same thing, octagon or octagonal box, octagon device box, 4 inches by 2 and 1/8 of an inch. So the 2 and 1/8 is the depth of that. And the 4 inches goes from one side to other side, because it's in the, if you extended those sides, you would get a square out of it. Then you only have to specify one side because all sides are equal here. And some of them are more equal than others. Like the longer ones are more equal and the shorter ones are less equal, but they're equal to each other. Got it. All right. So this here, from here to here, is 4 inches. There you go, 4 by 2.5, 2 and 1/8. And this one, because it's deeper, it can hold more of the 14 gauge conductors, for example. And if you want to use different gauge, you got to look at the tables. Then the one that is not as deep, see, the one that is shallower can hold less than the one that's deeper. Of course, because the one that's deeper will have more volume in milliliters or inches cubed. All right. All right, cool. Let's move. Let's move. All right. What does this one say here? Ceiling fixtures. This would be fixtures that would hold something, a little bit more weight, such as a ceiling fan. So some of the devices, like such a ceiling fan, are heavier, and they can't just be mounted on the drywall ceiling, for example, or in ceiling tile, because they're just too heavy. And if you mounted the ceiling fan just so it's held by the drywall, well, and if it's on top of your bed, that ceiling fan can come down on your face and while it's still spinning, and that would, of course, write it down, kids, would not be a very happy situation. Okay, so there you go. So, all right, let's see what it says. Ceiling fixtures often have what is called a hickey. What's a hickey? This thing right here, this little thingy that has threads on the bottom, thread on the top, and it's connected. So you can mount the top to something and you can mount the bottom to something else. This is called a hickey. All right. So ceiling fixtures often have what is called a hickey that attaches to the stud mounted in the ceiling box for hanging fixtures. So the box is attached to a framing, so the stud that is part of the framing, so it can hold weight. And then the box will have the thread, and you will use the hickey to mount things on, so the thing can be hung in a safe way so it does not fall on your face when you're sleeping. I hate when that happens every time. So so some of the fixtures, as I said, might need some extra, and you will basically have to consult or whatever the instructions come with the device. And sometimes you're gonna have to use common sense and follow the electrical code wherever you are. We're in Canada, so we're going to follow the Canadian code. All right, but I'm pretty sure that whatever is heavier in any other part of the world is going to require you to install it in a way that doesn't fall down. Okay? Unless you're in those places that it's okay to have things fall on you, but there will be a different code somewhere. Okay, got it, got it. Okay, this allows the weight of the fixture to be supported by the box and the stud. Stud is the 2x4, for example, that is mounted in the ceiling. It's part of the framing. All right, let's go. Octagonal boxes that holds a lamp holder, for example. This is a lamp holder right here. If somebody talks to you about a lamp holder, they're talking about this. This is the device that is called you got it, lamp holder. Anybody? Lamp holder, lamp holder. So that is the device that holds like you can screw in a light bulb right there. Okay. Now, what do we see here? We see an octagon box that is mounted to the stud. See, this is the stud, right? And see, there are those wings that you mount that box right so it rests on those wings, which enables you to have this surface of that stick forward about half inch to accommodate the thickness of the drywall. So when you install the drywalls on this whole wall, the drywall is going to be flush, nicely at the same height as the as this box sticking out, because the drywall thickness is half inch. Now you have two mounting screws, one here, and there are the mounting holes, and you have the mounting screws, one here, one here. And you know what? You just match them. You don't have to unscrew them all the way. You can just unscrew them high enough so you can stick in them, and you can kind of push and twist into place. So they go into screw, or they go into the narrower groove, and then you can fasten that. Just one thing is, because it's a plastic and this is metal, of course metal is stronger than plastic in this case, so I would suggest that you just do it with a feel. All right, do it with a feel. Do not kill the mounting here. Do not over tighten the screw, because the screw will just keep going if you tighten it. And this is a plastic, and it's just going to go right through it. You're going to damage that, and you're going to have to disconnect everything and get a new one, and then you're going to screw it not as tight. Right now, it also has, the box has a bonding terminal, and you can see that there is a bonding wire mounted. What I would do I inherited this PowerPoint. What I would do is I would make this bonding wire a little bit longer. It's too short for my liking. Right? Yes, it probably would pass the inspection, but make it a little bit longer. Create a little bit of a zigzag maybe, and then put that into the bonding terminal, just so the wire has some sort of a breathing space, breathing comfort in there. Um, and if you need to service that, replace this, replace that, the other thing, you still have some wire to play with as far as length, so you don't get yourself cut off, and then you're going to have to make a pigtail, and that's, that will be a second choice. What else do we have here? If you notice, I'm not sure if you noticed that or not, there are two terminals, two screw terminals, one double screw terminal here, one double screw terminal here. Same as a duplex receptacle, you can tell that these screws are silverish color and these screws are brass color. Brass is darker than silver, black is darker than white. You can kind of go that way, but you always make sure. What I would do is, if you have this device for the first time, there is a hot terminal on the other side, and we're going to see that from the front. The next slide. That hot terminal goes to that center connector that is deep in the opening there, and the neutral terminal is connected directly to the thread on the outside, or that hugs. It's on the inside, but it basically goes around the excuse me, the whole opening. Right? If you don't know which one is which, try to eyeball it. If you're still not sure because you can't see the connections, then get the continuity meter. And well, don't do it while this thing is live. Don't do it while this thing is connected. Just take it out of the circuit, or before you mount it, you can use continuity meter to make sure which this is connected to which. And of course, the neutral has to be on the outside thread, and the hot has to be on that middle center point. Right? We'll take a look at that. There you go. Here's a lamp holder, front and back. Okay. So here we have the center point. It accommodates a regular size light bulb. And over here is the thread. So the thread is connected to the silver screws, which is the neutral. And the center point, center connector right here, is connected to the brass screw, and that's going to be the hot, which is the black. It's where all the energy comes from. And the neutral is where the energy returns to, or from that, it returns to the electrical panel. And here are the silver screws, and here are the brass screws. That's what it looks like at the rear. That's what it looks like at the front. All right. Next slide. All right. Wire connections, basically, which what it is what we were talking about, but just a little bit more writing. Wire connections to common devices, duplex receptacle, black or red conductor to brass screw. Okay? Got it. White conductor to the silver screw. But I explained that to you, how to look at it. There's a shorter prong and there's a longer prong. Which is hot? Which is it that you remember? How to remember which one is hot? Well, hot, it just 3 letters. And neutral is longer word. So the hot one is the shorter prong because it's a shorter word. And the neutral is a longer prong, so we can connect it to the neutral. That's another way of remember. And then here's an insulated, or sorry, uninsulated bare copper conductor to the box connection, and to the green screw, which is the screw terminal for the bonding terminal. Also, it says bare, but in some cases, you're going to have a jacketed conductor. And when it comes to grounding or bonding, uh, we should use an insulator of bare copper or green jacket, and that's the color code for bonding. Lamp holder, which we just what we are talking about. Um, Black or red. Uh, sorry, black conductor. Bottom connects to the silver screws. No, that's another one here. What the heck? It just jumped on us. Lamp holder. Black or red conductor to the brass screw, white conductor to the silver screw, and it's uninsulated, of course, goes to the box connection only because we can't connect anything to the plastic because it's just, yeah, we can, but it's not going to do anything, right? Because it's an isolator, it's a dielectric, it's a material, plastic is a material that doesn't conduct electricity. All right, we have wire connection, single pole switch, black conductor to the bottom connection screw. It's a trade practice. The conductor is connected to the circuit breaker for this circuit live wire. So try to put it on the bottom. If you put it on the top, nothing's gonna happen, but try to have it from the bottom if you can help it, right? Because sometimes it's more practical to do it the other way. Black or red, top connect, black or what? Oh, see, there's a bit of confusion. So we're going to have to settle this one out, right? No, when the two-wire cable is used to operate the switch, the white conductor is used as live wire. That you might want to skip that note. Right. Okay, now let's go to the switches. Remember we were talking about single pole switch. What does it mean that it's a single pole switch? I'm going to bring out my board, which is basically the Photoshop here. Well, what we could have is, let's say we have some sort of a power supply and we're going to continue to a load, which let's say it's a resistor. All right, and we're going to come back and go back right to the power supply. So we have one continuous current flow, which basically goes from the positive, goes through the load and comes back into the power supply. So it's in this case, we're calling a closed circuit because there is a current pathway provided and it's closed current pathway. So it's a closed circuit. If we interrupt the wire, let's say somewhere here, well, we have something that's called an open circuit. What other kind of circuit could we have? If something comes across here and just shorts the power supply, this would be called a short circuit, but we are not going to make any of those, are we? All right, so we can install a switch here. There we go. We have a switch. So we have push button switch. Or we could just have a regular switch. So you can either close this switch or you can open this switch. Right? Single pole, because there's only one pole here. Single throw, because you can only throw it here and nowhere else. So we are dealing with something that's called single pole, single throw switch, single pole, SPST, single pole, single throw switch. If you had another terminal that you could either throw the pole here or here, then it would be a single pole because we're still having a single pole. But it would be a double throw switch. And from this, we could have a conductor going out of that, and we could have it going to another load, and we can either connect that pole into this one here, which would make this resistor active, or we can throw it here, the pole here, and which will make the other resistor active and the other one not active. So this would be a single pole double throw, which brings me to the other switch right here, which is this one. But first, let's look at the single pole. So that will be the single pole. Notice one thing here. I'm going to bring your attention to this. This one has a screw terminal for the grounding or bonding. And so does this one. And so does that one there. Here's the grounding terminal or the bonding terminal right here. Quite often, you're going to get the switches, and there's nothing wrong with that. You're going to get the switches without the bonding terminal. Because remember what I told you? How this thing is bonded or grounded. The chassis of this is metal. So this screw right here, this mounting screw, and there's another, this mounting screw right here, would connect to the bonding terminal on either of this plastic box, or if this whole box were all metal, then yes, it would still connect to the box. So in this case, there's no need to have that extra bonding screw because, well, the connection is being provided physically and is being fastened by this screw. So single pole switch, here's one terminal, here's another terminal. You can call it a two-way switch also, but it's called single pole switch. There's also a three-way switch, and there's also a four-way switch that we're looking at here. Now, let's say what the difference is between the three-way switch and a four-way switch. Just forget the bonding terminal. We are looking at the working connections. How many ways can you get in to this switch? A one, a two, a three. That's it. Three-way switch. And of course, if you don't count the bonding terminal, how many ways can you get into this switch? Well, a one, a two, a three, four. Okay, so that's a four-way switch. Let's skip the working conditions of the four-way switch. I want you to get the idea, the difference between this two-way switch or single pole switch and the three-way switch. There is some terminology that is involved in this. Let's just clear the board and take a look at that. So you see that you only have in here, you only have one, two, three ways. One of the terminals is called common. The other terminal is called a traveler, and there's also called a traveler. What's the idea with that? Let's take a look at this. All right. Say we have those terminals of that switch. There are three terminals. And there is a pole that goes here, or that pole also can jump into here. So either this or that. There's no any other option. And because this one is going to be common to both of them, then why don't we call it a common? And what do we have also? It says traveler and traveler. Okay, well, let's call these two travelers. Traveler, just like the person who travels across the country. Okay, same word, traveler. Here's a common, there's a traveler, and here's a traveler. So you could have a conductor going to this one, this terminal. You can have a conductor going to this terminal, and you can have a conductor going to this terminal. Now, if you had that switch in your hand and those terminals were not labeled, and you know it's a three-way switch, how would you test with the continuity meter? Because, well, before you put it in circuit, so it has to be out of the circuit, completely removed, and then you can put a continuity tester onto it. So you would just switch the multimeter into the continuity tester, right? Right. How would you, if they were not labeled, how would you find out which is which? All right, we're online here, so I'm not gonna use the time to do the anybody thing. All right, if this switch is positioned, or popularly called flipped, this way, the way it is, these two are connected. So if you put a continuity tester between this point and this point, you will get a 0 ohms, and you're going to have that beep on that continuity tester, which means these two are connected. All right. If you connected this point and this point, you're going to have an open until you flip the switch this way. And then you're going to have that. All right. So you will know that. Now, if we put a continuity meter between this point and this point right here, no matter which way we flip the switch, these two will never be connected. So you only have few possibilities to connect your meter to it. And if you find the two of those three that no matter how you flip the switch, they never make connection, then you know that these two are travelers. So the third one must be common. And you can confirm that by putting one lead onto here and one lead into here, and see if you flip it one way, it makes a connection. And if you flip the switch the other way, the connection is going to disappear. So then you put the test lead onto this one here just to confirm that this is the one that's connected to the common while the switch is flipped the other way. All right, so this is how you would, basically that's how it works, this three-way switch. All right. And then there's a four-way switch, which is a little bit slightly different than double pull, double throw. So I'm going to leave that out for now. Let's get the concept between these two. And you just have to identify that this is a four-way switch. We're going to play with these two. We're going to play with this one. We're going to play with especially this one here when we do our last lab, which is connecting a three-way switch system. What is a three-way switch system? I'm going to erase this. All right, let's say you have a basement in a house. So here is your basement. And from the basement, there is a stairwell here that leads to the second or the first floor of your house. And in the basement, there is a light bulb. There's a light. There you go. And here is a light switch here. And there's a light switch on top of the stairs. And here is you walking on the stairs because you're going to see your favorite TV show because something happens. Somebody, okay, you're walking up the stairs and you forgot to turn the light off. Well, if it's a three-way switch system, there is opportunity for you that you can flip this switch and turn the light off. So you can control the same light from two different switches. But, and we're going to go over how that is being arranged, we're going to have to install those two switches. Yeah. Oh, come on, let me grab that. Those two switches, this switch and this switch here, they have to be what is called the three-way switch. That's what makes it possible. And we'll go over how to connect that. And we will show you on during the lab how you can actually do that without looking at the diagram if it's not a too complicated situation. Also, there's going to be assignment. Assignment will involve presenting three different situations of connecting the three-way switch system in a way that the power could be provided to the light bulb location or the load, or the power could be provided to the switch in the middle, or the power could be provided to the switch at the end of the run. You're going to present three, but don't worry, I'll show you how to do that. And all you have to do is basically follow my instructions. So here is an example of a three-way switch system. These are a little bit older drawings. So what happens is that two things I'm going to point you to. One is right now with the new electrical code that we have, the current electrical, and we are in the year 2022. Now we have to extend the neutral wire to all the boxes. Whether we use it or not, it has to be there. So here's a pigtail right here that extends the hot. Here's a pigtail that extends the other hot or bonding wire, should I say. Yes, that's a bonding wire, not the other hot. Yeah. Except it doesn't look like it's green, but it should be. Or maybe they are trying to point out that it's a bare copper wire. So they're trying to put the copper color. And you would have to make another pigtail over here that extends the neutral wire to this box. And you're going to have to make another pigtail out of there that extends the neutral wire into this box. And now you're legal. But in some of the old installations, you will see that not always the neutral wire is extended. In new installation, or if you want to bring it up to code, you have to extend that. There's a reason for that. I'm not going to get into it. Also, it's not a common practice use now because you're going to have to supply the wires that contain the correct colors, but you will also see in some of the older installations. Look, this is neutral because it's white. Right? This is neutral wire. This is the bare copper for the bonding. And this is the black wire, which is hot. And look, it's connected to white wire because you only have so many conductors in that cable. So you're going to see in some old situations that there's electrical tape wrapped around it, that white wire. And it is not that somebody wrapped some tape around and forgot to remove it. No, it is to let you know that this wire is marked. It's jacketed white, but because of the electrical tape marking on it, or sometimes it's just a permanent marking, you are going to, this is to let you know that this white wire is not to be used, it's not used as a neutral wire, it's used as a hot or switched hot wire. So I would don't spend too much time on it yet, but familiarize yourself and try to figure out how this thing works. And later on, I will show you how this thing works. But try to figure out how this thing works, because you have neutral. Neutral. You have the common here, and you have a two travelers. Common and two travelers, common and two travelers. Try to draw it out and see how it works on your own. But later on, I'll show you how this thing works. And you will, trust me, you will be able to connect a simple three-way switch without even looking at the diagram, and you will do a correct legal way. Right? Here's another visual representation of the same thing, so I'm not going to go over that. Right. This is the box that we play with right now during our labs. So last week, some of us already have done it, and some of us we're going to continue with that lab too. Utility box. It's a single gang box. It's all metal. Now I understand this is we're coming to the end of the time. It's like we have 8 minutes uh, to finish. So I'm going to go a little bit over. So if you have to go to another class, by all means go. But I'm going to continue, and you can catch the rest of the thing when I post it on YouTube. I just want to finish that thing properly. All right, so here is a single gang, because it's 2 inches, 2 inches here and 3 inches here. Is this a gangable box? No, you can't take it apart. It's just one piece. It's got knockouts. It's got 2 mounting screws for the device, and it has mounting holes, screw holes, and to mount that thing on. It's called utility box or handy box, or sometimes handyman's box. All right, so that's the common one. Also, we have connectors that go different type of wires or cables or devices, such as EMT, which is electrical metallic tubing. Then different connectors will have to be applied for different purpose. There's also that plastic connector. You see this one here? It has the set screw and a pinching platform here. And that thing, when you turn the set screw, this holding pincher is going to come down and hold the cable in place. And this part right here goes into the knockout, and we use the lock nut to fasten to the other side. To fasten this, oh, I can't talk. To fasten this connector to the box so it holds. Also, you can quite often you're going to see these devices, which are okay too. It's a plastic one. You just squeeze it. See, there's a room for you to squeeze that. Squeeze it with 2 fingers. So this whole diameter of the whole thing becomes smaller. You can insert that into the knockout. I'm not sure if you can see it properly here, and release. And that is going to be held by the knockout hole or opening. It's right here. There's a little bit of groove right here. It's kind of bulging out. And then it has a one-way valve, if you will. And when you insert the wire or cable through that, it's going to let you through one way. But if you, because it's on an angle, you try to pull it back, it's going to stop it. So these are much quicker to install. Do I prefer the metal ones? Yeah, but these are quicker to install, and they're also legal. Right? So here is a device box that is basically used as a junction box. And these connectors are there. And of course, it's a timber framing, so we can use the NMD90 cable mounted straight to the timber framing. Right. Now, connection box connectors for EMT. There's one, and there's the other one. This EMT connector connects to the box. You see, here's the connector. You insert the EMT, which is electrical metallic tubing, which is a pipe. Right? And this one looks like it's a 1/2 inch one, so it accommodates a 1/2 inch EMT, which is a electrical metallic tubing, which is a pipe that is 1/2 inch on the inside diameter, plus the thickness of the pipe, of the wall of the pipe. And here is a lock nut, yeah, and that goes into the knockout, and the lock nut comes from the other side, so that thing is mounted just like that. And of course, there's a set screw that pushes that basically holds the EMT in place. Right? So that's one way of doing it. Also, sometimes you may have to use more than one length of the EMT, because the EMT, they come in, usually they would come in, that's a common thing, they come in 10-foot lengths, so it's easier to transport in your van, in a working van or working truck. But sometimes you're going to have to create a cable run that is longer than 10 feet. So you might have to combine 2 or 3 of those. So it's a coupler, because you're going to have to couple those. Let's say if it's 25 feet, you're going to have 10 feet plus 10 feet plus maybe 5 feet. So I'll give you 25 feet. So you're going to have to use 2 of those couplers. So in this case, you insert a EMT on one way, in one way here, and it's the other way, the same thing. You insert, just continue, just to extend that. And here's a set screw that holds it in place. And there's also a set screw that's missing here that is also going to hold that in place. And one thing I'm going to point out to you is this is not meant to hold weight. It's just to hold those things in places so they look nice, rigid, and they look, well, presentable, and provide a clear way. The EMT, if it's on the wall, it should be mounted using fasteners, the holding devices. It'll just look like a little hooks, and then just grab it and hold that against the wall, for example, or against the timber framing. Well, the reason why I'm mentioning this thing here now is because I've seen it a lot of times. Because sometimes you use it for electrical installations, and sometimes you're going to use it for some other things, such as data, for example. Mounting cameras is a common point using EMT. Let's say there's a ceiling here. There's a ceiling here, and the camera is specified that is supposed to hang so many feet from the ceiling or so many feet above the ground. Let's make it straight, as straight as we can. And sometimes it is going to require to couple some of those. So let's say 10 feet here, and there's another 10, maybe 3 or 4 feet, just to get the camera, the security camera, to mount it on the box, and then there will be a security camera mounted here somewhere. Right? So then you're going to have to use that coupler, the one that we just showed you right here, this one here. And remember what I said? It's not meant to hold the weight. It's just to hold things in place. It was not designed that way. So if you magnify this, you're going to have a pipe or electrical metallic tubing coming one way, and there's another one, and they're going to be close together, and they're going to be held by that coupler with those 2 set screws here, and another set screw right here. And there will be a data wire usually run through that. Because they are not meant to hold weight, usually what I would do is I would drill a tiny, because you have to be careful, you could do it before you run the wires. Drill a hole maybe here, drill a hole maybe here, and run a like a steel cable and join them here, so to provide the safety for it. So if something lets go, it's not going to fall down on somebody's head. Or sometimes what people do is they drill a hole and they put in a screw right there through the thing, but through the metallic tubing and over here as well. And they drill and they basically put a screw right in. So it's being held as one piece. Do not use that coupler as something that can hold weight. Everything should be mounted or fastened to the wall or to this timber stud. All right, what else can we have here? Here is a box offset. It's a box offset connector. Because you see here, here is a device box, and those knockouts that are there to mount the, well, these are entry points. They are not flush with the bottom of that. They are raised a little bit. So what you can do is you can bend that pipe to create something that's called a box offset. So it accommodates the height. And the rest of the conduit as it continues down the wall is actually touching the wall or timber frame. So it is actually mounted properly and fastened. So you're going to create a box offset in our second last lab. We're going to learn how to create a basic of the basic pipe bends, and you're going to continue with the pipe bending as you go along, but I'm going to introduce you to the pipe bending. And we're going to make two box offsets. Those box offsets will be, let's say, there is a box. There is a box. There's a box here. One device box. And here is the surface. And somewhere here is going to be another box that's mounted to this or sitting on the surface. And on this height, there will be a knockout. And on this height, there will be a knockout. So you're going to create a box offset here, and you're going to continue down at surface level. And again, you're going to make another box offset that fits the height of the knockout. And if you think it's simple, if you're a beginner, then, well, you know what, we're gonna have some fun with that, right? So that's why we need to have that box offset created. So you could bend the pipe to it to create a box offset. Never use that. Basically, you can just have the box and kind of stretch the pipe and put it in. It's going to look like, don't do that, all right? So you can also, instead of bending the pipe, you can use the box offset connector that gives you the box offset while you do that. You can either do either one way or the other. Also, here's the last slide. I would encourage you, because now when your attention is being brought to this, whenever you walk into a building, you're going to see some of the surface run EMT. What's EMT? Electrical metallic tubing. EMT stands for electrical metallic tubing, which are basically the pipes. And there's a science that goes with that says EMT bending or pipe bending as well, because there are different pipes. Sometimes you have plastic pipes as well, and that plastic is not EMT, right? It's not metallic, right? But I would encourage you to watch and notice. And I bet a lot of us are going to go around the school and you're going to start noticing the EMT around on the surface of the wall, which is going to be surface round EMT. And some of it is painted, some of it is not. Just watch it and observe how things are being done. How would you do it? Just start watching the geometry of things, how those things are being, because they're not just bent as ad hoc, as just bend it so it fits. No, no, there's a specific way that those things are bent, and there's a whole science involved with that. And it's a lot of fun to learn, and it's even more fun to actually be comfortable and doing it for real. And it's even more fun to get paid for that. All right. So I would encourage you to notice some of that. And see, this is our lab. Here's the teacher's desk. Remember that? And there are a lot of those pipes being installed all over our lab. That's the whole purpose. So you learn. So keep noticing that, and little by little, we will get you introduced to the something that's called the pipe bending and mounting those pipes into device boxes. So we just talked about the boxes and devices, and we touched on some of the paraphernalia that goes with it, right? Okay, so that's it for today's lesson. Um, have a wonderful week. And remember, the tests that are going to be introduced or released today, later on in the afternoon, it only runs until Thursday night. It's still better than having 1 hour to do it at the set time. You can do it on your own time. So work with me on that one. All right. I stretch towards you a little bit. Then, well, it goes that way. Right? So that's it. And remember, today is Monday. But if you think about it, every day of the week is almost Friday. So with that happy thought, I'm going to let you continue with your day. Have a good one. Thank you. And here's the end button. Here it is. Thank you guys. Have a good one.